Sure. Okay. Oh, Colton Kellison, yes, with a K. All right, so we started chapter 4 with 4.3 because whoever wrote this book was Smoke McGregor. It doesn't make logical sense to start with what he wanted to start with in 4.1 and then go back to 4.3 because you have to have the knowledge in 4.3 to understand 4.1.
Shit. Sorry. I was gonna say that's why she said. Yeah.
So, section 4.1. This is where we definitely like the stuff that you guys did yesterday that we talked about on Wednesday. That's definitely above geometry level, trigonometry stuff. What we're doing today is way beyond. We're going to start with some review of geometry terms. You will need your pinky purple paper, okay? Just page 1.
I was gonna say we're going from 4.3 to 4.1. It's gotta be easier, right? Wait, this paper with the
Yep.
circle on it?
Yep. We're going to be using the big circle today.
Ow. How are we doing circles?
Okay, so today we're actually going to talk about why on earth, if we're in trigonometry, which is all about triangles, why the heck is there a circle?
Because circles are made up of triangles. I like that answer. If you put enough triangles around each other, it'll make a circle.
He's right. That's how pies
You
cut.
can't even look at me like I'm sorry.
Okay, so,
I agree with Connor.
okay, pi is good, so that's good to know.
It's good.
So, anyway, let's talk about angles that you've talked about. You don't even have to write this down if you don't want. I will let you know when you should probably start writing if you aren't. So, for example, I'll pick the easy one because we can. We know that there are right angles, right? A right angle is what? 90 degrees. Okay, so what other angle types do we know?
Acute.
Yep, what's acute?
Under 90. It's because it's cute.
Yep, and if it's under 90, it's also got to be what?
Over 0.
Over 0. Okay, what else do we know? What's on the other end? Do you remember? Obtuse, yep. Okay, obtuse is what?
Over 90, under 180.
Okay, correct. Obtuse angle is between 90 and 180. Those are the ones that we talk about in geometry class. But there are more angles than that. What there is, first of all, let me remind you, you do not have to write this down, but I would like you to remember basic geometry is that an angle is made up of 2 rays. Okay, it's not like, I remember that. It's like the first chapter of geometry where you talk about definitions and things. We're not doing anything like that. But please remember that a ray is one point, it's one directional, right? It starts and then it goes. So every angle is made up of 2 rays. You have one here and you have one there, wherever it is. Okay? There is something called the 0 angle.
That's a straight line.
It's not.
Oh.
Okay? A 0 angle is 0 degrees, go figure. It looks like this. Okay, that's not a straight line. It's a ray. But if I just told you that an angle is made up of 2 rays, where's the other ray?
On top of it.
Right, because it's 0 degrees.
No.
They're collinear is what it's called. Okay? Which you don't have to know. There is a 0 angle. Okay? We also have at the other end of this a 180 degree angle, which is called the straight angle. which that's your straight line. We talk about that in geometry. We talk about linear pairs. That's two angles that are on a straight line. They add up to 180 degrees. So it's just a straight line. In general, it's a straight angle. Do we ever call it that? No, but that's what it is. So we have angles from 0 to 180. Okay? Are there more angles than that?
Probably.
Yes.
Don't ask me that question.
Okay.
I mean, if you're looking
Probably.
I did.
Side angle of a huge triangle.
Okay.
That would be more than an obtuse angle.
Connor said a minute ago that a circle is made up of 360 degrees. Right?
I didn't in fact say that.
So my question is that an angle?
Yes.
Yeah. That's a degree.
Okay. It's also 50 degrees outside. Is that an angle?
Really? Okay. Wow. I love how we're talking about angles, talking about the temperature. That's so nice.
Just saying. I was making a point about the fact that you cannot just go based on units. So these are the ones that are the most common because these are ones that other than the straight angle, come in terms of triangles. Okay, straight angle, we get into lines and perpendicular and all the things. Like the two parallel lines with the transversal, and you have straight lines, 180 degrees. These are all formed with what I would call static formation. And you don't have to write that down. But if something is static, it's fixed. Okay, so like in geometry class, I would give you this and say, okay, here's your angle, whatever, it's angle P. And there it is, it's there. In trigonometry, this is one of the main differences. In trigonometry, we talk about dynamic angle formation.
If you start giving us like
You want us to write this down?
angles.
No, there's none.
Okay.
You want us to write this down?
Yeah, this is where you should probably be starting. So we haven't written anything else down. Trigonometry makes angles dynamically. And when you talk about the difference between static and dynamic, those are opposite words. So what is dynamic?
They move.
It means it's formed by movement. Static means it's just there. Okay, there's no movement involved. Dynamic means there's motion involved. So in trigonometry, our two rays actually have names. One of them is called the initial side. For the purpose of our class, and really most trigonometry classes, this is the case. We assume the initial side, that ray, has his, I don't know what you call that part of the ray, but has his starting point at the origin and always goes on to the positive x-axis. Okay, so this puts him, this is different because this is putting him on a coordinate plane. And these angles, you can imagine that they're always on the coordinate plane. Like I cannot think of a situation where it's not. So if I say to you, hey, it's a this degree angle, you imagine him on a coordinate plane. And that's really what you want to do. So this guy's called the initial side. When we talk about dynamic angle formation, what's happening is that your second ray starts out on top of this one as a 0 degree angle. And the angle itself is formed by moving. So this is your second ray and it starts moving around, and the amount of degrees that it sweeps out is the angle. Okay, so if the other side is called the terminal side. So I'll give you we'll go here. Okay. So this guy is called the terminal side.
Okay, wait, so why do we have this blue circle?
This would be the angle that we talk about. Okay, so that if I was going to estimate that, I would say that's probably like a 220 degree angle. Okay, depends on how accurate we want to be with my drawing. This is approximately a 220 degree angle, which I know because this is how many degrees? 180, and I've gone beyond 180. This would be 270 down here, correct? Okay, so we'll talk about that in just a second. Now, here's the deal with this though. So let me pause a second and tell you this is why there's 360 degrees in a circle. Because if you start here and you take this all the way back around, how many degrees is that? 360, because it's 90 here, 90 here, 90 here, and 90 here. And that's 360 degrees of angle travel. That's why a circle has 360 degrees. Now, so far, so good. What's bizarre is that you can keep going. So I could have, it is exactly like skateboard tricks. Okay, so how many degrees would that angle be?
540.
540. Okay, because it's a whole circle plus another 180. So when we talk about the fact, like if I said to you, hey, this is a let's see if I can, I don't want to, what do we got? Just a second. Let's say I said this is an 810 degree angle. Okay, it's 810 degree angle. It's not, you cannot any longer imagine it in a triangle because there's no triangle. Triangles are 180 degrees maximum. So you have to think about the fact that his initial side would start there, and you're talking about how many times would he go around. Okay, which we'll talk about how to find that in just a second. Correct. So this 180 degree angle would be 1, 2, and he would be here. Okay, it's 810. So the first thing I want you to understand is that angles can be more than 360 degrees. Okay, more than 360 degrees. What do you think happens?
When teachers laugh,
What do you can do it?
This is fun. You always know you're
That's a negative angle. Okay, so this would be negative 90 degrees.
Why is it gotta be clockwise?
Okay, so it's a good question. These, when we talk about regular old dynamic angle formation, you have an initial side and a terminal side, and you always go counterclockwise. Okay, so if I have this guy that's gone this way, he's going backwards. So if you've taken physics class and you remember that velocity is direction and speed and direction, this is similar. Velocity, speed, and direction. This is similar. So it's 90 degrees. The negative just means you're going the other way. Okay? So you can have positive angles, you can have negative angles. Now, here's the deal. This, you could say to somebody, hey, this is a negative 225 degree angle. And they would be like, what the heck am I supposed to do with that? We would like to have a frame of reference. We would like to have a frame of reference to put him in the coordinate plane in a normal spot. Okay? So there's something, this you should write down. There's something that is called a coterminal angle. So coterminal angles share the same terminal side. That's why it's called coterminal. But what that means is it's two different angles in the same position. Now let me pause a second and tell you, I want to make sure that you understand this. This dynamic angle formation means that there's no limit on how many angles we can have, positive or negative. Okay, we could talk about a 1,440 degree angle. Okay, and that is something that we need to be able to place on the coordinate plane so that it actually makes sense. What? 1,440.
I mean, that's better, but not by much.
No, not by much. Okay, so it's 4 actually. Yep. Okay, so what we need to be able to do, we're going to start by going this direction. So this guy, negative 90 degrees, he is also equal to what angle? Think about going the other direction. 1,440?
Oh, 1,400. I thought you said 1,040.
1,440.
Yeah, that is one.
Yep.
Yeah, okay.
Okay. So right here, this is negative 90 degrees. What is it also?
Positive 270.
270. Positive 270. So those two angles, because if I just drew this without his arrow,
So that means that's a total of 180.
no. If I just gave you this angle here, it could be either of those, right? It could be negative 90, it could be positive 270. Those are called coterminal angles. Okay, those are called coterminal angles. What we need to be able to do is take an angle.
And be able to find either or.
So let's go this way. Let's say 40 degrees. I'd like you to find me 2 coterminal angles with that. Yep. There are infinitely many. For sure, I'm confident you guys will get one. The other one requires a little bit of thinking outside the box. Not terrible, but
Got 2.
you got 2? What you got?
I got negative 320 and negative 680.
Not the one I was thinking of, but that's fine. Okay, so negative 320. Okay, negative 320 would be if you went this way around. Okay, if you go this way around, it would be negative 320. What's the other one that you said?
Negative 680.
How'd you get that one?
I just put 720 minus 40, and I made it negative.
Very sketchy. The way that you get negative 680 is you travel around in this direction again. And so you're really adding another 300 or subtracting another 360 degrees from that, which is 680. Essentially. I also would say that it's 400.
How is it 400?
Because you're going to go forward, right? So I start here, I start at 40 and I go around again, right? So if you can go backwards twice, you can go forwards twice. And then 760 and so on. There are an infinite number of coterminal angles. Now, here's where we have to be able to do this. And there's a reason, which I will get to, like, why do I have to do this? I'll get to you in just a second with that one. So let's say that we talk about 2,560 degrees. Okay. I would like you to find the coterminal angle that's between 0 and 360 degrees. So there are infinitely many of them that are coterminal. I'm asking for a specific one. The one that is between 0 and 360. There are multiple ways to get this answer. Oh my gosh. Maybe today is a lottery ticket day because that doesn't usually happen. Didn't expect that. That's why maybe I should buy a lottery ticket. It's lucky numbers, Javon. It's about lucky numbers. Just kidding. I've never bought a lottery ticket in my life.
Really, not one.
Not one.
I've never bought one, but I've done a couple scratch offs.
I've never
I've-
bought one, but I get one.
Yeah, I've been given ones. Most I've ever won is $1. So not worth it.
Yeah, I got like, we had like a saran wrap ball and it pulled apart with gum bits on it.
Yeah.
I got like 8 scratch offs, won like $3.
I know. So disappointing.
I got like 2 and
It's 40 again. Okay, so here's what you're doing. You can imagine my 25, 60 degrees. And you guys, I made that number up. I had no idea what it's going to be. I'm going to need to know what it looks like, but it's like how many times around, and then it ended up here. But I kind of got to know where it ends up. And the only way to do that is essentially to unwind, kind of like Grayson was talking about, the saran wrap ball. You're unwinding this, so you just start subtracting 360. Just start subtracting the 360s until you are between 0 and 360. Okay, I know that some of you are dividing by 360. You got to be careful because then you got to be careful. I'll just say that. So I'll show you. Just subtract 360 until you get to the number that's between 0 and 360. Let me show you what your calculator does a second. I don't know if you guys know this. This is just going to make this easier. You don't have to type in 360 minus 360 every time. Okay, so if you do your starting point, 2560, and you hit enter, and then just minus 360, and then you can just hit enter. You do not have to continually type minus 360. It will just go. There you go.
So, that's not what we got. I got
I don't know how you got that because this is the number we're working on. There's only one thing.
Well, what I got was 7.1.
That's when you divide it.
That's when we
You got
divided.
extra 360?
We got 30,200.
I'm clear.
Listen, you can keep going, but you need to stop when you get the one that's between 0 and 360. You got to stop.
Yeah,
Okay.
I got that part.
Okay. So same idea. Let's say we had a negative 1976 degrees. I'd like you to find the coterminal angle between 0 and 360 again.
Cup of coffee.
Me?
Yeah.
Why? No. I thought you said I needed some. Oh, I don't have any. Okay, so here's my question. If you take your negative 1976, if you take that and you start subtracting 360s, if you take it and start subtracting 360s, what will happen?
You can go more negative.
You're going to go more negative. So what do you have to do? You add the 360s on this one. So you're going the other way around. So what do you get? Yep, 184 degrees. the reason that we want to know this is if I said to you, hey, I need you to graph this angle, you got to know where it is. It's 184, which really is here, right? There's your negative 17, 1976 this way. There it is. Okay, so either add 360 or subtract 360 is how you find coterminal angles. Super easy. Correct, because you're trying to get back to essentially 0 at 360. Now, what I want you to do is take this paper, which yours is pinky purple, mine is not. So what we have here is a big circle. This is a coordinate plane. We're gonna, over the next week, we'll have this filled in, but today we're just working on this part. So we're gonna fill in the degrees. So this is 0. So we're gonna put the degrees where the little circles are because that's what degrees are. This is 30. So we're moving counterclockwise. Then we have 45, and then we have 60. Now, I'm going to pause before we go farther and let you know that this is 30, 60, 90 triangle and 45, 45, 90 triangle. So those are the special right triangles, and those are the ones that figure in here. 30, 60, 30, 60, and 45. Okay. What's this guy up at the top? How many degrees? Yeah. Okay. This one is 120 degrees. That's just another 30 beyond. This is 135. This is 150. And what's this guy? 180 degrees. On our circle, we only put the positive ones because those are primarily we want to be in the positives. That's why we were asking for coterminals between 0 and 360. This one's 210. This is 225 and 240. What's the bottom? Yep. And then over here is 300, 315, 330. Now, if you want, it would be a good idea to pop the 360 on there also. Even though those are coterminal, we do care about 360 degrees. Okay, you can set that to the side. I do not think we will need it anymore today. Yeah, don't put it away. Don't put it away. Okay.
Is this on a new page worthy or no?
Yeah. Okay, now, you know that we have, on our calculators, switched them from radian mode to degree mode. Okay, there's a difference, obviously, because we have to switch it on our calculator. So, I'm going to talk about what is a radian, like what the heck is it, and then eventually we will get to switching between radians and degrees, like how do you convert. So radians is just another way to measure angles. Okay, degrees is what we're used to because that's what we do in geometry. But in radians, mathy, like upper level math people like to use radians because they don't have units. A degree is a unit. A radian doesn't have a unit. So it could be measured in feet. It could have whatever units that you need it to. And so it makes more sense logically for people in upper level math. That's the best I got on that. So, okay. So, no. So, that was a pretty good circle, which I would just like to say. So imagine this circle, and If you have a small circle, what's going to be true about your radius?
You're small.
It's going to be small. If you have a big circle, what's going to be true about its radius? It's going to be a bigger radius. So the size of the circle depends on the size of the radius, right? Size of the circle depends on the size of the radius. So imagine if we took this radius and we could bend it and lay it along the outside of the circle. Okay, so pick this up and stick it along the circumference. Okay, so here's my question. Well, that's not a question actually. This measurement right here is 1 radian. Okay, so I'm going to explain it again. I don't really think it's worth writing down, but a radian happens if you take the radius of a circle and you lay it around the outside. That arc measures off 1 radian. Okay, so that's the angle in the middle. It's also the length of the arc because that's how geometry works. It's called the central angle. It's the same as the arc. So 1 radian right here. How many radians do you think you can fit in 1 circle? What does it look like? Just a second, let me shade it because I got a couple of different things here. Okay, so this is 1 radian. How many of those do you think we can fit in 1 circle? 10 is a little bit much. Whoever said.
I'll take 5.
You take 5.
5.
6 is the closest whole number.
6.5.
Okay, so I want you to think about this. Okay, that's 1 radian. When we're talking about going around the outside of the circle, what's that called? Okay, what's the formula for circumference?
Is it 6.2831?
It is. Okay. So this tells you that the outside of the circle, it is up there. This tells you that the outside of the circle is how many radii? It tells you that it's 2 pi radii. Radius is, but radii. So 2 times pi is 6.28. So if you guessed 6, pretty darn close. Okay. So what that tells us is that there are 2 pi radians in an entire circle. They're called radians, told you that. We also know that there are 360 degrees in 1 circle. So we use this information to convert between the 2 of them. Okay, now, radians have a couple funny rules.
So each radian is like 57.29.
Yes, but, yeah, that's totally fine to say that. The thing about radians is that we never write them as decimals. Okay, radians, number 1, are always written in terms of pi. Okay, and they're always fractions, no decimals. Okay, so we're going to talk about, or start talking about, no, we're not, because it's 58. This is a good place to stop. So on Monday, we're going to come back and talk about how do you switch between radians and degrees, because unless you've been doing this a long time, somebody's going to be like, hey, why don't you graph pi over 4 radians? And you're going to be like, I don't know what that is. You want to be able to put them in terms of degrees so you can graph them. So we're going to talk about how do you convert between those. So that's where we will pick up on Monday.